So this is only for EC, electrical, instrumentation departments like that. Okay. For computer science, only these first three topics. I think 7 marks you can expect if you are from computer science electrical. If you are from EC instrumentation, around 10 marks, 10, 11 marks. Okay. So that's how marks get distributed. 6, 7 if you are computer science and electrical. So if you ask me more in detail, what kind of questions do they ask? Okay. Here, I have seen questions based on different bases. Base 2 to 8, base 2 to 10. Some weird bases, base 5, base 6, base 7. They can ask anything they have asked. It's not that they can ask, they have asked. So you should be able to convert from any base to any base. So questions based on that have been repeatedly asked. And the other thing is complements. You all know what complements. So obviously it's an important topic. Based on this also, I've seen lots of questions. And there is this one topic called IEEE floating point. 754 floating point. So based on three topics, only they will ask questions here. For computer science, there is a 100% question. I've seen this for EC electrical also recent years. So mostly you will definitely get one mark or 2 marks putting these three all together. Okay. So this is something that you should think of. Then in combination circuits, what kind of questions do they ask? Questions based on basic Boolean expression reduction. And then there is a question on basic logic gates and some combination circuits like adder, subtractor, and then multiplexer, decoder. Okay. 2 marks. I've seen lots of question papers with 4 marks. Okay. So here you can expect 1 to 2 mark. Here you can expect around 2 to 4 marks. And then here there is this flip-flops D, J, K, T. Basic flip-flop analysis set. Some counter analysis questions. They'll give you a counter circuit. They will ask you what is the next state, or maybe what is the state diagram. What is the next state? What is the state diagram? Such questions, like it's like forever. Such questions are there forever. Like you can think that question is there. You go into the question paper, you will definitely see that question. So this question is most likely 100% there. The same thing like this Boolean expression reduction. That questions are there forever. Without that, they cannot make a question paper. And then there is this transition diagram. It's also similar. 100% there. So this, again, here you can expect around 2 to 4 marks. Okay. So this is how you can expect questions. So by the end of this tomorrow's day, you should make sure that you could solve all these questions. And I would suggest you to bring previous year GATE question bank. We have a GATE question bank. I think some of the years might be missing, which is unfortunate. You should have a question bank till 2024. So you should be looking at such questions, and then if you have it at home, kindly bring it tomorrow. There, if you are computer science, I think you will have some 2-3 chapters in the subject. You should solve all these questions. And apart from this, for circuit branches, there is some questions based on memories. We'll talk a little bit about that. Maybe logic gates, CMOS logic gates. So this is what is the syllabus for this subject. This is a easy subject. Somewhere here and there, maybe the concepts are a little bit too much, but otherwise, subject is very basic, easy. Unlike other subjects, this is a simple subject. Only we are going to talk at the system level. We are not going to talk very deep at the circuit level. So that means that the subject is basically easier subject. Preamble to this, what should we say? What do you understand by this word base? What's the meaning of the word base? Base. What do you understand by the word base? So that's very important number system. Base. Base, radix, radix. Base or radix? Both mean the same. What is the meaning? Something else? What do you think of this word base? Base or radix? They both mean the same. What is the meaning of the word? Okay. How many symbols? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally how many symbols are there here? Number of unique. Unique means they are all different symbols. How many symbols are there? 10. So that makes us to call that the base for this number system, the base for this number system is 10. So what is the meaning of the word base? Okay. Radix or base. What is the meaning? Number of unique symbols. So here we have 10 symbols. So the base is 10. What will be the next number? I use this color. What will be the next number? Next, this number is called 9. What is the next number? 10. How do you represent number 10? We cannot introduce new symbol because we have restricted the number of. So 10 means it is made like this. And how do you make 11? The idea is you cannot introduce new symbol. The new symbol is restricted. You can keep making it. I'm sure everybody here knows it. Let us say I am talking about a base of well-known base 2. I don't want to use this thing. 2 base 2. Base 2 means how many symbols are there? How many symbols are there? 2 symbols. What are the symbols? 0, 1. And what is the next number called? 2. How do you represent 2? Can we introduce new symbol? No. So the number should be represented by only available symbols. So I kind of combine them like this. And what is the next number called? 3. How do you represent 3? What is the next number called? Oh, how do you? Okay, so I kind of guess that you people all know this. I'll extend this for, see, I'm going to give you a random base. I don't want to give random base. Let's use what is base 8. How many symbols are there? 8 symbols. Can you just give a shot? We started with the number system. See, where did we start? We started with this. This is our syllabus. Number system, combinational circuits, sequential circuits. If you are a electrical or computer science, you can expect 6-7 marks. If you are from other departments, you should expect around 10 to 11-12 marks, depending on the question paper. We started with base. We just wanted to discuss a little bit about base. So we started with this base, meaning number of unique symbols. So if there are 10 unique symbols, in some language 10 means deci, so they call this number system as, in some language 10 means deci, so they call this number system as, in some language 2 means binary, so they call this number system as, and in some language 8 means octal, so they call this number system as octal number system. And by the way, what are the symbols here? What are the unique symbols here? Unique symbols is 0, 1, 2, 3, 4, 5, 6, 7. Can I introduce 8 here? No. The number of unique symbols should be only 8. So the number of unique symbols is restricted to 8. So the next number, which is 8, has to be represented by only available symbols. So 1, 0. So what will be the next number called? 9. And 9, how do you represent 9? 1, 1. So you keep doing like this. Spend some time. It is not at all difficult stuff. It's a basic math stuff. Number system. How do you make a numbers? How do you write a number? Sir, ingo vaanga. Sit here, sir. Okay. Now there is what is one basic concept we gave? Base. What is the meaning of base? There is one more small idea I will add. After that, this concept will be complete. Which color shall we use? Green. Okay. See, how do we say that this number is 2? How do we say this number is 2? For every position, there is a meaning. So there is a concept called positional value. There is a concept called positional value. What is the meaning of this? Every position has a value. What is the value? What is the positional value here? 2 power 0, 2 power 1, 2 power 0, 2 power 1. And what is the positional value here? 8 power 0, 8 power 1. And what is the positional value here? 8 power 0, 8 power 1. What is the positional value here? 10 power 0, 10 power 1. So now tell me, where is this 10 power 0, 2 power 0 all coming from? From base. If your base is 2, the positional value here is 2 power 0, 2 power 1, it keeps increasing. And if the base is 8, here it is 8 power 0, 8 power 1, it keeps increasing. So there are only two concepts that you should know in number system. One is called base. Base means what? Number of unique symbols. And the second is positional value. Every position has a value. Every position has a value. If it is base 2, this is 2 power 0, 2 power 1. This is 8 power 0, 8 power 1. Okay. Now, see, we just discussed this. Let us say I want to write a number 16, in base 8. How do you write a number 16? So next 15 minutes, we are going to express any number I give you. I want you to express it in any base. Okay. Now I say 16. I want you to write it in base 8. How do you write it? 16. Base 8. So how many 8s are there in 16? 2 8s. So what you can do is, another color I will use. Like this one. So there are 2 8s and 8 power 0 is 1. So they don't need any 1. So this is called 16. Is that fine? Now I say 17. What will be 17? 2 1. Well done. How do you say that? Yes. 2 1 is 17. If I say 20, the number 20. Yes. 2 4. What is this called? 20. See if you get it. So 3 numbers we have done. 16, 17, 20. Can you express 16 in base 2? How do you write 16 in base 2? Take your time. This is what is called converting from one base to another base. You slowly go. There is nothing new. There are only 2 basic concepts you should know. The idea of base, and the next is the idea of positional value. By the way, this is not new to us. Usually we call this position as ones position. Have you heard of this? What is this position called? Tens position. And what will be the next position called? Hundreds. And what will be the next called? Thousands. Now tell me, what is this position called? Ones. And what is this one called? Eights position. Why? 8 is there, no? What will be the next position called? 64s. 64. Why 8 square? No. So 64s. Now tell me, what is this position called? Ones. And how about this one? Twos. And what will be the next? Done. That's it. This is number system. You should be able to name the positional value. If you can name the positional value, you can definitely get a numbers represented in any position. Now the next target is, I want you to represent number 16 in base 2. Maybe you should copy this for some time. If you have some doubts here, kindly ask your neighbor. If you can't answer, I can answer. This is the easiest subject. You put a little bit effort, you will get all the marks. Okay. In all of your whichever syllabus, whichever department, The easiest part is digital. You should not miss. Remember, all you need is 25 marks to qualify. We can get 6, 7, 10 marks here only. Super. All right. Now I'm going to in base 2. Base 2. Let me name the positions. What is the first position called? Ones. And this position, two. And here, fours. And how about this? Right. 16s. How many 16s are there? Yeah. Now the number, what is the number we are interested in? 16. How do you represent number 16? No, yes. The number 16 can be represented as 1. Agreed? And what is the base we are talking about? So it is customary to write the base here because you should not get confused. No, what base you are working in. So you should write that base here, whichever base it is. And the next is, what is the number you were talking? How about 17? What do you say about 17? 1, okay. And we need 1 here. And all others are? And how about 20? 1, 0. Well done. And as usual, always remember we are talking about positional values. So every position has a value. This is base 2. Okay, so let us say that what you have done is actually converted a base 10 to base 2. What if I give you this? Another color. What would you do that with this? Every position has a value, and that value you should know. If you know that, it's very basic, simple. Ten. Okay. How about 4 ones? No. So this will be 10. And if I say, what will this be? 8 plus 4 plus 2 plus 1. So it should be I'll give a generalized picture. You just have to know this. Okay. Only this much is there in number system. Now, what did I give you? I gave you some base, any base n. For example, the previous case, we did this. How to do base 2 to base 10? Multiply by. So you multiply with each other, what do you get? Multiply by positions. So when you multiply by positions, you get back the base 10. I'm going to stop here for a few minutes. And for example, if this is given, how do you achieve this one? Divide by. You can do this, or you can always do this. You can always do this. This is it. This is all about number system. Slowly do problems. You will get used to it. How do you convert from any base to base 10? This is the only thing that you should have in mind. For example, if I give you a number which is in say I want you to 1 4, it is in base 5. I want you to convert to base 7. What do you do? The only thing that we know is from any base you can go to base 10. We do not have any method to directly jump from n to any other base. You have to go to base 10 and then only. Can you attempt this? Meaning of base means, what is the meaning of base? Number of symbols. Unique symbols, correct. If I say base 5, how many symbols are there? 5 symbols. What are those symbols? We already know the symbols. 0, 1, 2, 3, 4. That's all. No more symbols. What is the positional value for 1, 4? 5 power 0, 5 power 1. So you will have to bring from base n, base 5 to base 10. What do? You multiply with the positions. then what do you get? Okay. So here it is 5 power multiply by positions. What do you get? 9. And then you'll have to divide by 7. Whatever remains here, quotient here, remainder here, whatever remains. So it will be, again, do not forget, we are working with a positional value. This is it.
Can you say rank based on conversion of to the base answer?
Okay. So we'll think of it like this. So base 7 now, how many symbols are there? 7 symbols. 0, 1, 2, 3, 4, 5, 6. How do you represent 7? 1, 0. Number 7 is 1, 0. Number 8 will be? Number 9 will be? Okay, got it. Okay. அப்படியே சொல்லலாம். Or you can say you can divide by 7. When you divide by 7, the quotient you will write, the remainder you will write, that's it. Quotient is, there is 1, 7, and the remainder is 2. See, how will be the gate questions? Just based on this, I'm going to manipulate this basic idea into gate questions. Gate questions will be like this. 1, 4, x equal to 1, 2, y. Find x and y. How will you find? We already know the answer. 5 and 7. Correct. Good. How will you find? This is the gate question. This is how gate questions will be. Not just to find x and y. I have seen gate questions where they ask how many possible solutions are there for x and y. How many possible solutions are there for x and y? Is it only one solution? Is it a unique solution? Or multiple solutions are possible? If so, how many solutions? Such gate questions are repeatedly asked, particularly for computer science. So there are 2 questions I am asking. One is this. The other is how many possible solutions for x and y? All right. So how do you do this problem when you see such a problem? Always remember, there is only one thing I have discussed, that is this. Bring everything to base 10. We have only discussed that bring everything to base 10. Now, how do you bring this to base 10? Bring this to base 10, bring this to base 10. How do you do that? To bring anything to base 10, so what is this one? Now, what is this? Whenever you write like this, what is the base now? So the final equation will be so this is the equation that I've got. Can we say x is 10, y equal to 12? Is it fine? Is there any condition that it should be so and so, anything like that? Can I say x is 1, y is 2, y is 3? Can we say x equal to 1, then y equal to 3? Is this correct or not? Yes, no? The answer is no. Wrong. Why? If I say x equal to 1, what is the meaning here? Base is 1. How many symbols are there in 1? Sir, if x is 1 means there is only one symbol. Only one symbol. But here already I have two different symbols. So this is not possible, no? So what is the minimum possible value of x? If it is 2, then what are the symbols? Minimum 5 symbols, sir. Why? I have 4 here. So the condition is, the moment you see this, first thing that you should run in your mind is x should be greater than 4, greater than or equal to 5. And y should be greater than 2. No. Yeah, 2. Okay. So because that is the biggest number, no? Should the number of symbols should be greater than that. So obviously this is not a possibility. So the solution starts from x being 5 and y being 7. You can have infinite solutions. So how many solutions are possible here? Infinity. And what is the minimum possible solution? 5 and 7. Nothing less than that. There is the answer. Spend some time, you will understand. This is how they ask gate questions. What is it? Find x and y, that is minimum possible x and y. And what are the different types of solutions? How many number of solutions possible? So the answer here is infinity. Here, find minimum, meaning 5 and 7. X plus 2 equal to y, sir. Same questions. Find minimum number of solutions. So all the gate questions will revolve around the same thing. Two different bases equated. How do you do it? Bring everything to base 10. Bring everything to base 10. Whatever you see, bring everything to base 10. That is the only thing you know. How do you bring everything to base 10? Multiplying by positions. That's all. Sir? 1 minute, sir. What is the equation you are getting? X plus 5 equals 5 plus 2. So what do you? And you should always remember what is the most important part here. Conditions. The most important part is these conditions. What are the conditions here? Inequalities. You should say inequality. What is the inequality here? What is the conditions here? What should be the value of x? Range of x? Very good. X should be less than 5. Because you cannot have a symbol that is greater than 5. The number of symbols is only 5. You should have less than 5. And how about y? Greater than 2. Now you have conditions. Impose these conditions on this equation. Tell me what are the possible solutions. Base means number of unique symbols. They say unique symbol is 5. That means you know the symbols already. 0, 1, 2, 3, 4. You cannot go beyond 4. So x can take 0, 1, 2, 3, 4. Done. And how about y then? 3. So how many solutions are possible? What do they expect from you? This is what they expect from any competitive exam you give. This is the maximum they will expect from you. Of course, this is all for whole numbers. We have to do for fractional numbers. All right. Time to come back to digital, this basic number system. If you have a number 153 base is 10, can you convert it to base 2? So I hope everybody is giving this year exam, no? February exam. So pay attention. We are going to do 12 hours. At the end of this 12 hours, you will definitely get 7 marks. Okay. So whenever you are losing interest, pull up yourself. These 2 days will definitely fetch you 7 marks. Okay. Whenever you feel bored, go get coffee, come back. So how do you convert base 10 to base 2? You can do division, a safe technique. What do you start with a simple, how do you divide? With what number do you divide? Divide by 2. 2. Divide by 2. And then tell me what is the expanded form. Okay. So I kind of expect everybody to do this division. And what is this? 70?
76.
So you kind of write like this. This is the most significant part. So the important thing is the most significant part. You can do this, or otherwise you can. I always remember this, and I would, as you get more and more experience, you should do this way. I mean, as you solve more and more problems, I mean, you should remember this. At least till 2 power 8. What is this one called? $256. All right. So here I see 153. What is the biggest number possible? 128. So this is possible. So I'm going to say here 1. And after you subtract 128, what is left? 25, sir. 25. So 25 means in 25, what can you have? So you can have a 1 here. And you remove 16 from this. What is left? 9. Okay. 8 is possibility. So remove 8 from this. What is left? All right. So you can say, from this you can say 1, 0, 0, 1, 1, 0, 0, 1. See, we got this. It's all the same. I'm just putting it things in different. What we did is we saw how many 128s are there. 128 is there. And how many 16s are there? 116 is there. How many 8 is there? How many 1 is there? If I give you any number, you should be able to say no. If I say just 128, in binary, what will it be? 1 and how many zeros? Nah, 7 zeros. 7 zeros, right? 1 7. So you can do all that. Okay. See, what comes next is, now the problem with binary is binary number system is lengthy. This is a problem. So we'll have to shrink it. How do we do shrink? Now, for example, we got a number, something like this. I want to shrink this. So what they did, so to address this problem, they went on grouping it. When you group 2 bits from right to left, you can actually reduce the size. You can group 2 bits, 3 bits, 4 bits, whatever. When you group 2 bits, what is the new symbol you will give for this? When you group 2 bits, binary digit, bit means binary digit. When you group 2 bits, what is the new symbol you will give for this? What will be the new symbol? Now that's a tricky situation, right? So let's write all possibilities for grouping 2. All possibilities. What are all the possibilities for grouping 2 bits? 0 0, 0 1, 1 0 1. That's all. This is all. Now let's give a new symbol for each and every. Maybe I'll use a different color. Yellow. Yellow not used. So 0, 1, 2, 3. Now I will call this as 1, and this one will be 2, and this one will be 1, and this one will be 2. So this will be 2 1, 2 1. But what is the base? How many symbols do I have? 4 symbols. 4 symbols. In other words, base. So we started with binary. We say that binary is lengthy. We dislike it. Why do we dislike it? Communication between the programmers. As a programmer, if I tell you 153 in binary, I have to say 1 0 0 1 1, all that. So to avoid this complexity, what they did, they kind of grouped. They grouped 2 bits. Base 4, in some language 4 means quarter. So they call this number system as quaternary number system. Okay, I think this R will come. Quaternary. So this is called quaternary. Bi means 2, so binary. This is called quaternary. They were not satisfied. They went on grouping for 3 bits. Write all possibilities for 3 bits. How many symbols you will get? If you write 3 bits, how many symbols do you will have? 8. So that language, that number system will be called. Go on, attempt it. They were not satisfied with 3 bits also. They went on for 4 bits. What is the first type of question today we did? Any base to any base conversion. Second type of question is this, particularly base 2. They are more interested in base 2. After all, computers, everything works on base 2. But the problem with base 2 is it's lengthy. Interested in reducing the length. What is the purpose of reducing the length? Communication between the programmers. Two people are talking, you want to communicate a number 153. You cannot keep saying that 100, so on. So they kind of wanted to reduce it. Now grouping 3 bits. When you group 3 bits, what are the possibilities? See, there is a method in writing this one. How do you write this method? First you LSB you make 0, 1. And then the next will be that 0, 1 you will write, and then 1, 1. See, this 0 will become 1. And then how about next? You will copy this 8, 4 thing, and then you will make this one. First you do this, copy this here, then make these two as 1. Then you copy the whole 4 here, and then make this MSB. How to write? There is an ordered fashion. You should know how to write the ordered fashion. You cannot write it in a disordered fashion. As we go along, we will figure out why. There is an ordered fashion to write this one. And let's give new symbols to this. What will be? Here it will be. So if you have to reduce this number, now how do you group it? 1 is missing, so you can maybe add 0. What will be this called? Always remember, we are all talking about positional number system. It's not that we randomly do. Every position has a value. Now the next is grouping 4 bits. Last thing they stopped here. How many possibilities will you get? How do you group 4 bits? What are the unique symbols?
0, 2, 0.
What do you do? Why A? Why not this? Why not this? All the symbols should be unique. We cannot use all available symbols. So you can always use any symbol you like. Okay. They copied our number system, they gave their symbols. So when you combine, what do you get? What is this? What is the positional value? What is the name of this number system? Hexa means 6, decimal means 10. So put together hexadecimal. They don't even have a name for the number 16. So they just said 6 plus 10, 16. All right. So what kind of gate questions do they ask? They ask something like this. What do you do? So how do you do? Always remember hexadecimal and octal are directly linked to base 2. So what you can do, you can ungroup this to base 2, regroup it to base 8. So ungroup, what is 9? 1001. 99 is 100. So you will get something like that on the top. Again, you regroup it from the left, 3 bits. Something that we did here. Ungroup it to base 2. See, there are two ways to achieve the solution. One is you can go to base 10, which is the actual way, and then come here. Or otherwise, you can always go to base 2 and go here. The best technique is this: ungroup and regroup. Two. So this is how they ask: base 16 to base 8, base 8 to base 16. Just to confirm that you know that how base 2 works. All right. This is all about number system. finishing touch. What is 10 on the top called? 10. And what is 100? The last one. 100. What is 10 here? What is 100 here? 4. How about the next? Base 8. In base 8, what is 10 called? What is 77 called? What is 100 called? 64. 8 power 2. 64. Then what is 77 called? 1 less. 64 ஒன்று குறைச்சிக்கோங்க சார். என்ன வரும்? 63. அதே மாதிரி இங்க என்ன 10? What is 10? பேஸ் என்னவோ அதேதான் சார். 10. 16. What is 11? 17. What is 100? 16 power 2. 256. Then what is the FF? 255. That's everything. So 10 does not mean 10 always. 10 can be anything. 100 can be anything depending on the base. I did not write one thing here, and that one thing is this. What is this number called? What is this number called then? What is this one called? Positional value. Just to cross check, if I ask you to convert FF, which is in base 16, to base 8, what is the answer? FF, it is in base 16. Convert to base 8. FF, it is in base 16. Convert to base 8.
base 16 to base 8.
Next question, AB.CD. AB decimal point CD. AB.CD in base 16 convert to base 8. This was a gate question. AB.CD base 16 to base 8. Uh, but anyways, it does not matter here. I just wanted to give the question values. What is base 2? A in sir, base 2 A. Now comes the tricky part. How do we combine it? You should combine from the decimal point left, from the decimal point right. Maybe I'll use a different color. So you should combine like this. What do you end up doing? So it will be 2 point basic stuff over. Fractional numbers, how do you handle fractional numbers? How do you do? Again, there are multiple ways to figure it out. 13. 13 means what is the biggest possible number? 2 power 3, 8. No? So here 1. And if you remove 8 from this, what is left? 13 minus 8 is? So out of 5, what is remaining? 4. So rest all will be agreed, no? What is 2 power minus 1? What is 2 power minus 2? So here we have a 0.25. See, 13 can be written as 8 plus 4 plus 1. 13 can be written as 8 plus 4 plus 1. So that's how I landed up there. And 0.25 can be written as 0.01. After all, when you multiply the positional values, you should get back the same number. Cross check if you are doing it. When you multiply back the positions, you should get back the same number. Does it come? Let's cross check. When you try to go back, multiply by the positions. I got it. So what I did is I did this reverse. 13 can be written as like this. And then I extended this here. Then I put 1 here. 0.25 can be written as this. And then I put a 1 here. Rest also. Just to cross verify if you can do this. Base means number of symbols. Every position has a value. My small suggestion is you try to remember at least till this. This much you should definitely know. No excuse. So what can you write? 14 can be written as 8 plus 4 plus 2. And 0.625 can be written as 0.5 plus 0.125. So this will be 1110 point. Check if everybody gets this. 0.625 can be written as 0.5 plus 0.125. 0.625 can be written as 0.5 plus 0.125. Okay. So anyways, there is a proper method to do this fractional numbers. I'll introduce that. If you have a number like 0.25, you want to convert this to base 2 The proper method is like this. Multiply this with base 2 and then you get, and then you take only this part, 1.0. You get nothing. That's it. This is a proper method. The same thing you can do for how do you do this one then? What is this? Okay, only take this part. Okay. So this is a proper method. If you think the previous technique is good, you can do it. But if they end up giving you 0.33, then only this one works. Let us say the number is 9.33. 9.33 base 10 to base 2. 9.33. How do you solve it? Maybe I might ask you what is base 16. The question is, let us say I extend the question to this. What do you do? First you go to base 2 and then you go to so it keeps going, no? What is next? 0.642. So it keeps going. It's a cycle. So what is 9? This is the MSB. So it keeps going, I stop here. So this can be written as, what is this one? 9. It keeps going, I kind of stop there. Okay, so this is all about fractional numbers, converting from any base to any base. Sure, you all can do now. One or two questions. Check. Take a picture of this first page. Or a photo of the first. First page full update. Can you attempt the first question? அப்படியே எல்லாம் full page எடுத்துக்கோங்க சார், photo எடுத்துட்டு pass it on. Yeah, first page, first second page எடுத்துக்கோங்க. First second. There is computer science, sir. How is your preparation in other subjects? How is your preparation, sir? You have seen questions? Almost? Very good. See, we only covered electronic devices. Electronic devices, most of our content we covered. Analog we covered. Network we covered. EMT we covered. Digital we are covering. Almost 50 marks we covered. Okay. In 50 marks, even if you can get 30, 35 plus, enough now you will get decent rank. If you can get most of it, you will get a very good rank. Okay. I tried resolving most of the previous year problems. Most of the questions will come from previous year problems. Okay. Nothing, only whatever I've covered, only whatever subjects we covered only here will cross more than 50 marks. Okay. That you should have at least covered by now. Next 1 month, you should do only revision. This one you can add. After this, do not study anything new. Only 1 month is there. Only study that you have studied. Nothing new you should touch. Only practice, practice, practice. Revision. Every day, try to cover whatever you have done. Revise, revise, revise. All the previous year problems that you have solved, you revise them again and again and again. Start with question number 1, 2, 3, whatever you want to solve. We'll move on to the next topics. Complements will do, as IEEE floating point will do. Mostly 2 pages you take, sir, enough. We'll come back to these things later. You all got recent question banks, no? Recent question banks. The 2025 questions, some basic RC circuits they have asked. If you see, analog la போய் பாருங்க ஒரு diode zener RC வச்சு 2 mark question, easier 3-4 marks simple questions கேட்டிருக்காங்க பாத்தீங்களா பாருங்க. I saw 2025 question paper. I think most of the questions 2024. Sorry. Most of the questions that we solved, I've seen. Recently only saw the question paper. Next 1 month, every day, 6 hours preparation you should do. Only revise, revise, revise. Previous year questions. Discuss with your friends. Just target, don't target 80 marks, 90 marks, that never works. Target only 30 marks, 40 marks. I've seen people who target 30 marks, they end up getting 35, 40. Because when you don't do overkill, always target less, put more efforts on that. Make sure you are getting that 35, 40 marks. So in this, for example, for ECE, 9, 10 marks will come. The computer organization I will not do. 1 or 2 mark. For ECE, computer organization is there. Computer organization. There are lots of videos. There are lots of classes happening. I will not do computer organization. Okay. Computer in digital, for ECE, there is a topic called computer organization. That I will not do. Okay. That there are lots of people they teach for computer science here. Detailed and I will not do it. 1 or 2 mark has come previously. It's a miscellaneous content only I see, and I will not do it. I don't know actually. Then and I will do memories. I will do little bit ADC, DAC. I will do rest of everything. I will do. Okay. At this point of time, if you don't know computer organization, leave it. It is only 1 or 2 mark. Okay. Because it's only 1 month. Maybe next year you can add it. How about the first question? Can you solve the first question? First question. See if you can solve first question. Solve question number 1 and 2, 4. 1, 2, 4. One, two, four. What is the answer for question number 1? Option A, B, C, D. How about question number 2? How about question number 3? Sorry, not 3. 3. How about 4? How do you handle square roots? Yes. Squaring on both sides. Bring it to base 10. How do you bring it to base 10?
Square root r square plus 2r plus 1 square same d.
What is the question?
Not option any value all option கொடுத்திருக்காங்க இதுல எந்த ஆப்ஷன் டெசிமல் 10 r வந்து என்ன ரெண்டு ஆப்ஷன்
What should be the condition for R?
greater than
R should be?
greater than
Why?
2
Symbol 2 இருக்குல்ல 2 ஓட அதிகமா. So what is the option you will choose?
two option A D
ரெண்டுமே மேட்ச் ஆகுதா?
ரெண்டு கொடுத்திருக்காங்க டெசிமல் 10 கொடுத்தா அது மேட்ச் ஆகும் எனி வேல்யூ அப்படியே கேட்குது இஸ் ஆர் மல்டிபிள் செலக்டிவ்
Oh, okay. Look at the solution, what they have done. Sir, you have this question banks, EC question bank you have. 2025, 2024 question bank. 24, sir. That you should bring. Sir, 70-80% of the questions are from previous year questions only. The pattern will be the same. Not that every year something totally new will come. 70-80% of the question will be previous year. So your target should be bringing the question bank here, solving all the questions. That's what you're paying money. You pay so much money you paid and you come empty-handed.
option D or greater than 2 option D கொடுத்திருக்காங்க
Option
A
Option D. So option D. Huh? So any value of R will help this one. No? This equation will be satisfied for any value of R. Option D. Base 10, sir. How to bring it to base 10? Bringing it to base 10. The only thing I did is bringing it to base 10. Multiply by positions. Every position has a value. What is the positional value here? Are going right here. Multiply by positions. You bring it to base 10. Something like this was asked for EC, I guess. EC. Yes. Some different equation last year, 2024, 2023 for EC. Not this book. The book does not have it. 2024. Something like this was asked. They offered 2 marks, I guess. Go and check. All right. So this is all about the number system thing. Is there any other question worth solving?
Same.
He said that page 1 and 2. See if there is any other question worth solving. Is worth solving, you solve. Otherwise, if it is easier questions, leave it. See, after this 2 days class, you should put at least 3 full days, 6 into 3, 18 hours of efforts. Monday, Tuesday, Wednesday. After this 2 days class, put 3 days full efforts. Solve all the previous year gate questions till 2024. That will definitely fetch you at least, for example, out of 10, you will get 7, 8 marks. Like that, you do for 4, 5 subjects, you will get very good rank. You have come so much putting efforts. Last 1 month, you put 6 hours, only things that you have studied, nothing new. You get easily 40, 45 marks, which is a very good rank. It will not come easy. 180 hours you should put. 6 into 30. Okay. Compliments. Simple table is there, I'll make it. a 3-bit table. See, this table is all there in Morris Mano digital design book. Okay, I took this table from there only. Digital design by Morris Mano, first chapter only it will be there. The word complement means there are two complements in English: COMPLI, COMPLE. COMPLI means gift, COMPLE means opposite. So this word complement inherently means opposite. I'm not telling this just to teach you English. This is very important. Complement means opposite. Complement means opposite. So here they are using the word complement just to represent. We are talking about opposite. What is that opposite? We are going to come. Just to remember that complement means opposite. See, this is a 3-bit table. If you have copied, the next should be 4-bit table. Make a 4-bit table. Start with +7, end with -8. Next is 4-bit table. Start with +7, end with -8. Same, everything else is same. I want you to fill it up. This is a 3-bit table. Next is 4-bit table. Start with +7, end at -8. Four-bit table. Start with +7. If you start with +7, what will you have? If you have +7 here, it will be 0, 111. Go on, fill it up. It will be same for positive numbers. So what will be -0? -0 for 4-bit will be 1000, because the MSB represents the sign. Take your time. So this table is very important to understand 2's complements. Okay, you cannot escape it. My feeling is that the whole of the digital, the difficult part to understand is this 2's complement. Okay, the rest all you can understand somehow. This 2's complement takes a little bit of time. So don't rush. Before lunch, I'll make sure you understand. It's not difficult, but it needs some time. So when you start with +7 and end at -8, I think positive numbers you would have filled. How about negative numbers? 100, 1001. Okay, good enough. What happened to -8? No representation. No representation. All possibilities are round. See, for 3 bits, how many possibilities are there? 8 possibilities. No. 2 power 3. 8 possibilities. See, 8 possibilities are there. When you run out of the possibility, the final one becomes no representation. For 4-bit, how many possibilities are there? 2 power 4. 16 possibilities. And how about 1's complement? For 4-bit, 1's complement will be 4 1s. Just write it in the inverse fashion. Go on, fill it up. I have difficulty in this. You just leave one and then just copy it. Spend some time here. You'll get it. As I said, this is a bit of tricky part, so it will take 15-20 minutes. Same. See what he has done. Copy it, sir. Pass it on. What is the time? 12. What time we break for lunch? 1. Take a picture, pass it on, sir. Take your time, fill up the table. Some 5-10 minutes, you'll understand. But your instrumentation, no? How is all other subjects completed? Okay. You are going question bank. You have previous. You are solving all the questions. No, but you have solved all the questions. Right. Your weekdays also you have our time to study. Morning. Last year you gave okay. This is the first long back. Okay, that's it. You saw at least the last till questions. How are you finding?
Starting now it's better.
No, better.
Sir, yeah, more than 5 years.
5 years. Okay. It will take time. But you have been preparing for 6 months, no? Here at least more than 6 months.
Connected to
Very good.
some
Very
networks.
good. EMT questions. EMT questions.
Some basic questions.
Basic.
Databases and facts also, sir. So that
Very good. No, this divergence curl. Okay. How is the instrumentation questions? Biomedical. Biomedical. That questions are there. No? Biomedical subject is there.
sensors.
Okay.
Basic questions.
Basic questions. So mostly I.
Communication, some level to modulation.
Very good.
Modulation, demodulation. Both are like this.
See, this sensor questions mostly RC circuits. That is enough. Mostly. Not seen the questions. Measurements are already done. Measurements.
Basic DC systems like
Bridges and bridges question will come. When network theory also bridge questions will come. Okay. I hope you've got the tables. What are the types of the questions they ask? See, we'll write some notes. Okay, some points, notes. Put notes. First point, complements have got nothing to do with positive numbers. The complement representation has got nothing to do with positive numbers. Complement representation has got nothing to do with positive numbers. So when you see the table, what do we see here? For positive numbers, whatever binary, same. Second thing, MSB is 1 for negative numbers. For a complements, MSB is 1 for negative numbers. You make a note. Note 2 is for negative numbers, MSB is 1. MSB is 1. And then, see, in 2's complement representation, there is no separate, in 2's complement representation, there is no separate minus 0. Actually, does it even matter whether it is minus 0 plus 0? It doesn't matter, right? Zeros are same, minus or plus. So actually, there is no separate representation for minus 0 in 2's complement form. But in 1's complement form, these two are two different representations. Actually, whether it is the moment you say 0, it means in 2's complement form. Plus 0, minus 8 does not matter. But in 1's complement, there are two different representations. I've seen one ISRO question they have asked, why do we go for a 2's complement representation? The answer they say is, the correct option is, because 2's complement representation does not have a separate representation for minus 0. The question is, why 2's complement is better than 1's complement? The answer is, 2's complement does not have a separate representation for minus 0. Because it leads to a confusion. No, 0 means 0. There is nothing called minus 0 plus 0. And the next is, what is the range of numbers that you can represent? Range of numbers. What is the range of numbers you can represent in ones complement form and twos complement form. In a 3-bit, what is the range of numbers? Ones complement form means you can go from +3 to -3, sir. -4 does not have. But in twos complement form, you can go from +3 to -4. The range of numbers. Can you say something like that for 4-bit? For 4-bit, ones complement form will go from +7 to -7, and twos complement form will go from -8. So you can do all that. Now see, there is a question here. Question number 7. Can you tell me what is the answer for that? Question number 7 from the pictures you have taken. Question number 7. As I told you, twos complement is difficult, tricky, the most difficult part in the subject. Option A. Everybody agrees? Option A. How do you do it? Substitute a number. For example, put n equal to 3. What should be the answer? What complement are they talking about? One's complement, two's complement. Put n equal to 3 in option A. What is the answer you get? So what is the option? Is that option A correct? Okay. Check with the answers. There is answer. Question number 7. Check if the option A is correct. All right then. So this is all you can do. And how about binary? Binary also same like one's complement. Okay. Now the next question is, look at the table and tell me, what is the twos complement representation of +3? Write the question. What is the twos complement representation of +3? What is the twos complement representation of +3 in 3-bit form, 4-bit form, 5-bit form? Twos complement representation of +3 in 3-bit form, 4-bit form, 5-bit form. What is the answer? When you look at the table, what is that you have? For +3, what is twos complement representation? Same. So 0. What will be the 4-bit form? 0, 0. 5-bit form, what will be the answer? Okay, good. That's correct answer. And if I ask you that in 10-bit form, you can pad zeros. The idea is you have to copy the MSB. You have to copy the MSB. The MSB is 0 here. So you copied. So maybe you should make a note. As you save a smaller value in a bigger memory, for example, say you declare a variable as, say I declare a character variable. Character A is 3. Say the compiler allocates 8 bits. So it will be so many zeros and 1. Then immediately you say integer B equal to A. It is called typecasting. No? They call it typecasting. You save a one data type value into the other data type. When you do this typecasting, what does computer do? It copies the MSB. That's what we are doing now. Copies the MSB. Typecasting copies the MSB. And the reverse, vice versa, is also true. When you try to save a bigger value into a smaller memory, it truncates the MSB. It truncates the MSB. When you save a bigger value into a smaller memory, something has to be truncated. No, what gets truncated? Not the LSB part. MSB part gets truncated. We should make a note. A larger value into a smaller memory, MSB gets truncated. That's how your computers work. Larger value into a smaller memory. Say I declare my compiler allocates only 3 bits for a character data type. 3 bits means maximum and minimum number is this. But I try to save number 8 into it. What does the computer do? It truncates the MSB, it saves wrongly. How wrongly? That's what gate questions are. All right, then we'll go on. The next question is 2's complement representation of -3. 2's complement representation of -3. 2's complement representation of -3 in 3-bit form, 4-bit form, 5-bit form. Maybe we should add 2-bit form also. 2's complement representation of -3 in 3, 4, 5, finally 2-bit form. Two's complement representation of -3 in 3-bit form, 4-bit form, 5-bit form. I want you to do 2-bit form also. What happens? Now, I think this one you can look at the table. What is -3? 101. How about 4-bit form? Well done. How about 5-bit form? Okay. How about 2-bit form then? Apply the same logic. Computers do not have a mind of their own as of now. They are not intelligent. They just do whatever we say as of now. So, if you try to save -3 in 2-bit form, what is the answer?
0.
Truncates MSB. The final answer will be 0. So, what is that I try to say? Try to say that -3 in 2's complement form in 3-bit form it will be, 4-bit form it will be, now is this -3? No. Computer saves like this only. If they say a range of numbers, no. If you try to save any number away from the range, it will save it wrongly. How wrongly? So wrongly. Okay. Now I'll give you a gate question. Form. Use complement form of -17 in 5 bits. Some gate here. So there is a question here, 15. Maybe you can have attempt after that, after this. Maybe. So what's the point here? When you try to save a number in bigger memory, what are you doing? Copy the MSB. When you're trying to save a memory in a small value in a smaller memory, that's B to the smallest amount. How do you do this? Sir? சரி இப்போ இந்த டேபிள் எங்கேருந்து வந்ததுன்னு ஒரு கொஷின் இருக்குல்ல, how do you answer this question? See, some philosophical question, no? How did this table come from? No, it's not philosophical, it's basic stuff. Okay, see, maybe I will try to answer it from a different viewpoint, see if it helps. Sir, in the word taking 2's complement means what? What is the meaning of taking 2's complement? Complement na நம்ம என்ன சொன்னோம், opposite னு சொல்லிட்டோமா? அப்போ taking 2's complement na, for example, I have a number plus 3. If I say take 2's complement, take 2's complement, that means the final answer should be minus 3. Yeah, plus 3 in the opposite minus 3. Plus 3, how do you represent in 4-bit? You know the method of taking 2's complement. How do you take 2's complement? Invert all the bits, add 1 you can do. Or otherwise you can say from the right end you write the 1 and invert all other bits. There is one other technique. Invert all the bits, add 1. So now you go to the table, 4-bit table. In that 4-bit table, see minus 3 is represented like this. That is how I got the table. You understand, sir? What is the idea? Taking 2's complement means inverting the sign. Taking 2's complement means, noun verb rendu. Taking means verb, we are doing action. Noun means 2's complement representation of. Now, question 2's complement representation of plus 3, 2's complement representation of minus 3. That is noun pair. You know, taking 2's complement verb. Okay. There are 2 types of questions. One is noun based, verbal based. All right then. So now let's cross check. I have a number called plus 7. How does it look like? It looks like this. I take a 2's complement of plus 7, which represents minus 7. Go and look at the table, see if you have this one. That's how we make the table. I take plus numbers. I know how did you get this one first? 7 positional values. 2 power 0, 2 power 1, 2 power 2. அதை வச்சு இது பண்ணிட்டோம். இங்க அந்த பொசிஷனல் வேல்யூ சப்ஸ்டிட்யூட் பண்ண அப்ளை பண்ண முடியுமா? பண்ண முடியாது. அது இதை எழுதிக்கணும். For negative 2's complement representation, positional does not hold any positional values. Negative 2's complement representation does not have any positional values. Negative 2's complement representation does not have any positional values. Negative 2's complement representation does not have any positional values. நீங்க அந்த 2 பவர்ல இங்க சப்ஸ்டிட்யூட் பண்ணக்கூடாது. Only for positive numbers. Okay, let me attempt plus minus 17. First of all, minus 17 வந்து எந்த range of how many bits do you need? 5 bits is sufficient. Number 3 bit la what is the range? 3 bit la what is the range? 4 bit la 5 bit la so this one needs other first understanding. First understanding is this number minus 17 needs 6 bits. First you try to represent this in 6 bits. Appuram truncate the MSB. That is the answer. First you try to represent minus 17 in 6 bits. Why do I say 6 bits? Because that is the number, that is where this range, that range is what helps. I'm going to stop here and see if we have understood this completely. Take your time, take your time. So where do you start this? First is represent plus 17 in 6 bits, then take 2's complement. How do you represent plus 17 in 6 bits? Plus 17 in 6 bits. Plus 17. Plus 17 in 6 bits. How to represent plus 17 in 6 bits? First to represent plus 17 in 6 bits. How do you represent? 0, 1, 6 bits. Now what do you do? Bob. What do you get when you take invert? What is this number? What will be the final answer then?
0.
Is it minus 17 now? No. Computer is wrongly saving. But this is how it will save. See if we can attempt this one. 15. Sir, direct negative numbers நம்மளால represent பண்ண முடியாது. Why? Because there is no positional value. So you cannot do it. Start with positive numbers. Take 2's complement. See, the idea is when you take 2's complement, positive number will become negative number. When you take 2's complement of negative number, it will become correct. When you take 2's complement, plus will become minus, minus will become plus. In a complement, the word inherently means opposite. Plus minus ஆயிடும், minus plus ஆயிடும். அதனுடைய opposite தான். When you take 2's complement, what you are doing is finding the opposite polarity. Plus becomes minus, minus becomes plus. When you take 2's complement. say 7 minus 3. 7, when I take 2's complement of plus 3, what will be the number? When you take 2's complement, plus 3 will become minus 3. So I can just add this 7 plus of minus 3. I'll get the same answer. So that is why whenever you have a minus b, we write a plus b's 2's complement. You have seen, no? You can do complements. You can, when you take complement, that inherently means that minus plus b has become minus b. So இங்கே minus இருக்கு, இங்கே மறுபடியும் இன்னொரு minus, இங்க plus பண்ணாலே போதும். So can you attempt this one? What is 7 in 4-bit form? 7 in 4-bit form is? What is 3 in 4-bit form? Now this can be written as, what is the 2's complement form of this? Add it, what is the answer? You all know addition, no? Binary addition. So the extra bit you are getting is called carry. You should reject the carry. The very important part is when you are working with the data type, say character data type, the memory is limited to 8 bits. If it is a GCC compiler, memory is limited to 8 bits. If you say I have a 9th bit, your data type say get lost, I don't want. I have only 8 bits, I will only save 8 bits. So the carry is rejected. So that's what happens here also. When you try to add, what happens? Am I correct? I made a mistake somewhere. Okay. And then you get a carry. What do you say do the carry? So the final answer is, what is 7 minus 3? 4. See, I got 4. Can you do 3 minus 7? What should be the answer? See if you are getting minus 4. When you take 2's complement of 7, what happens? Minus 7. How does it look like? By double 1? Okay. Are you sure? Oh yeah, something like that. So the question is this. What is the 2's complement of this? You should know, you cannot make mistake here. 2's complement form, how to take 2's complement. Invert all the bits, add 1, that's all, that's what I did. Okay, so what happens when you add this? So the final answer is, this represents -4. You look at the table, you'll see this represents -4. See, one small point I have seen in lots of gate questions, they give this one, they give this question. In the choice, you will have 5-bit A, B, C, D. One or two choices will have 5-bit. They will have 10100. That's not a correct option. Computers always neglect the carry. When you are dealing with 4-bit, option also should be 4-bit. If you see 5-bit, neglect, reject. Okay. So that is something very important to remember. So this is about 2's complement. I think only this much is there. I don't think there is any other type of questions you can expect. What are the types of questions we attempted? We attempted what is the 2's complement representation of a number, whether it is positive or negative, bigger memory, smaller memory. If we are talking about smaller memory, truncate the MSB, all that we did. And the second type is, how do you handle the subtraction? You don't have to do subtraction. You can just use an adder circuit and do subtraction. How do you do it? Use the 2's complement. Okay, so this is all about 2's complement form. We'll just talk a little bit about this IEEE format, and then we'll end this session. You have any questions? Is there any problem you would like to solve in that question bank? What is the question? 2's complement of, give a shot, sir, give a shot. Please do it. Question number 18. 18. So what is the number they want you to represent? Minus 500 and 539. So it's a negative number. So you have to start with positive number, take 2's complement. How do you represent plus 539? Looks like maybe you can do division. 539 and 2 वाले divide पन्टे पोंगे. 539 divided by 2. Quotient remainder, get a positive form. How many bits they are asking you? How many bits they are asking you? Options are in hexadecimal. ரெண்டு மூணு டிஜிட், மூணு ஹெக்ஸாடெசிமல் டிஜிட் அப்படின்னா எத்தனை சார்? எத்தனை பைனரி டிஜிட்? ஹெக்ஸாடெசிமல்ல மூணு மூணு இருக்கு, 12 bits. So you should understand they are asking you to represent it in the 12 bit form. How do I say that? Hexadecimal மூணு பிட், மூணு டிஜிட். டெசிமல் தான் டிஜிட் சொல்லுவாங்க, பிட்னா பைனரி டிஜிட். Friends, ஒரு ஸ்மால் இது, if I want to take 2's complement, how do you take 2's complement for this one? Simple, invert all bits, add 1, or otherwise what is the other technique I said? Till the first one you copy it and then only you invert. The method of 2's complement is, இப்படி இருக்குன்னா எப்படி இன்வெர்ட் பண்ணுவீங்க? ஃபர்ஸ்ட் 1 எழுதிட்டு மீதி எல்லாம் இன்வெர்ட் பண்ணு. அதே இப்படி இருக்குன்னா ஜீரோஸ் இருக்கு, you have to keep writing till the first one. I don't want you to make mistake. Till the first one அப்படியே காப்பி அடிச்சிடணும். இங்க first one காப்பி அடிச்சோமா, till the first one you have to copy, rest only you should invert. Till the first one you should copy exactly, taking 2's complement, then only you should invert. I don't see sound wave for floating point. Sound wave for floating point. I don't see sound wave for that is the next topic. Small topic that is only one page. For example, I do single precision. Sine wave via the exponent and sine wave is only one bit. One bit. How many is the bias exponent? This one definitely is the image is using on. Sounds.
Something on me.
8 weeks. 8. Is it real source? Uh, See, if you want to represent no, example, see, if you declare a variable as floating point, how does your computer save it in your memory? That is what this is. It seems that this is very important, so they expect you to know the world of AI, where it's all digital signal processing. Floating point numbers are unavoidable. Most of them are floating point. So, how about if I put in the diagram, it's 85.125. It is in the decimal. Now they want you to save it in floating point single precision, not just some binary. It is IEEE floating point. How does it save? This is the question. Solve it here. Now, how do you represent 85 separately? Tell me. I think that's easy. 85. What's the biggest number there? 64. If you need 64, how much is there? 21. Out of 21, what is the biggest number? 24 and 21. 5 is there. No, so 4 plus. So this can be written as what is 64? 2 power. So this can be written as how to convert decimal to binary. How do you convert this one? 0.125. 0.125 is like this. Okay. 2 power minus 3. 0.125, 2 power minus 3. Now, how do you represent this? So if you put together, it looks like this: 1, 0, 1, 0, 1, 0, 1, 0.001. Okay. Now, IEEE format says bring it like this: 1 point something. What is 1.010101? How many points did we jump? So you should say this into 2 power minus plus 6. 2 power plus 6. How do we say this? This is not new to you. You would have studied that if someone says 6.023 into 10 power 3, what is the meaning of this? Same thing I did in the binary word. What is it? I move the decimal point, so into 2 power 1. So this is called exponent. This is called exponent. This is called Mandy-Sal. This is neglect. So what will be the final answer? Final answer should be what? How do you get biased exponent? Biased exponent is 127, which is a standard number that you add to 6. So what is the number you get? What is this in base 2? See, this is a constant. Point to remember, this is a constant that keeps coming to me. But constant. So that's how when you have minus numbers, you can solve it. What do you have here?
1 0 0 0 0
1 0 0
0
0 1 0 8 bits. No? Okay. So we try to add this. So the final should be, what is the sign? Positive number, negative number? This is a positive number. So 0. What is the exponent, biased exponent? And what is the matrix of our 0, 1, 0, 1? 0, 1, 2, 0, now 0, 1, and then rest all unit up with zeros. This is the identity form. Tell me what is the answer they are saying. Now convert this to another 4 bit group is hexadecimal. What will be hexadecimal value? What is the hexadecimal value they are giving? What is that they are saying? The answer should be 42A, A4. Check if you are getting this one. So when you group this one, it will be 4, and when you group this one, it will be 2, and this will be A, A, 4,